Hey there, here we are, 4.4b factoring trinomials with a greater than 1 or a leading coefficient again. Instead of doing the guess and check method though, we're going to give you some tools to be able to handle the situation if guessing and checking is not working. And sometimes there's so many combinations that checking every combination gets overwhelming. It's a good practice to have. It's a good skill to be able to get through, but this method will always work if it's factorable. In fact, we're going to do two methods here to answer our essential question of how do we factor. Factor trinomials a greater than 1 methods. Maybe there's a stronger word for that maybe. But this is going to be a process or an algorithm that's always going to work versus guessing and checking. How do I make it a question? How do I? We'll be able to answer that here in a little bit. Might need some practice with it though besides these examples. So first method, split the middle technique. This is nice because you're going to use a diamond and you're going to use factor by grouping. Factor by grouping we covered a couple of sections ago. That skill will help you here as well. So I'm going to do example number 1 and refer back to the 7-step process here. So step number 1, write the polynomial in standard form. It's done for example 1, and it usually will be. Step 2, simplify by pulling out any GCFs, if any exist, and there is no GCF there in that polynomial. Multiply a times c. Now if you're like, well, what's a times c? Look up here, folks. A is your coefficient of x squared. C is the constant, or the number without a variable. So sometimes I like to kind of go like this. I did 2 times 3, which is 6. All right. List the factors of 6. Yeah, I started kind of putting in a diamond because we're going to try to multiply that 6. Remember, your 2 negatives multiply to a positive as well. List the factors. Look for a pair that add up to b. And our b is the coefficient of x. So I'm actually trying to multiply to 6 and add to 7. Which pair does that? 1 and 6. But here's where things are different. And it's different because of this leading coefficient. We can't just put parentheses down and an x at the start of each binomial, because it's not going to be x times x. It's going to be 2x times x. But we're not guessing and checking, so let's proceed with the process. Rewrite the polynomial with the 2 terms for b in the center with the variable. So the variable that we're using here in this one is x. So rewrite the polynomial with the 2 terms for b in the center with the variable. And actually what I like to do in this diamond is I like to actually, so remember how we had this 1 and 6 here? Make it 1x and 6x. We're going to rewrite this polynomial, but instead of writing 7x, I'm going to write 1x plus 6x, because that is 7x. Like this is these 2 lines, although I need to write the plus 3. These 2 lines, the typed line and my handwritten line, is equivalent. I know it seems silly that I split 7x into 1x plus 6x, but we are able to do factor by grouping right now. If I would have tried any of these other combinations for this middle section right here, right here, factor by grouping will not work, so we can't go anywhere. But now we can factor by grouping, and we will actually be able to completely factor this polynomial. Remember, factor by grouping, hug the first 2, hug the last 2. And now factor out of the first 2. This is a funny sentence. So out of this first binomial, I can factor an x out, and then I'm left with 2x plus 1. Out of the second binomial, I can factor a 3 out, a positive 3, so I'll write plus 3. And then I'm left with 2x plus 1. Remember, for factor by grouping, these binomials that remain should be the same, and they are. And once that happens, we take our GCFs and we put them together. Positive x plus 3 times 2x plus 1. Or vice versa. You could have your binomials switch because the order of multiplication does not matter. That, folks, is the factored form. It's factored completely. And if you FOIL that together, you get that. It is factored. Let's try it again here for example number 2. So remember, we're going to make our diamond, but we're not going to put multiplying to negative 11. We're going to put multiplying to 3 times negative 11, which is negative 33. So factors of 33, ways to multiply to negative 33, and add to 32. So 33. And it's a negative 33. So 1 and 33. Negative 1 and 33. 1 and negative 33. Negative 3, 11. 3, negative 11. Ways that add to positive 32 would be this one right here. So now here comes the first difference. Well, the second difference really. Put x's with this. Because we're going to not rewrite it as 32x. We're going to rewrite it as negative 1x plus 33x. You know what? I'm going to put the 33x first. It doesn't matter. Oh, plus 33x first. But if you look at factor by grouping, some people don't like when there isn't much of a number to factor out. And in this case, it's going to happen either way. But sometimes when you rearrange it, it factors differently and people like it better. But in the end, you will get the same correct answer. Sorry, this is a little pinched in there, folks. So here's my first binomial. Here's the second binomial. Make sure you add the opposite here on that third term. Boop, boop. All right, so out of the first parentheses, I can factor out a 3 and an x. So I'm left with x plus 11. Out of the second parentheses, ooh, so now I can't factor a number out of that, except for, remember, with factor by grouping, you always factor a number out. If you say there is no number, you can always factor out a 1, because you do need to have a number right here in factor by grouping, just like you need to have a GCF out in front of that one. However, we actually aren't going to factor a 1 out, because if I factored a 1 out, my binomials right here wouldn't match. They'd be opposites. So I need to factor out a negative 1. Because when I divide or factor out a negative 1, I'm left with a positive x and a positive 11. So now they match. So we put 3x minus 1. We put the GCFs together, even if it's a negative 1 or a positive 1. That GCF needs to get factored out, and then x plus 11. So that is what we call split the middle. And this method I like better than the method down below, but a lot of students like the method down below better. I like this method because we're really using skills that we already have. We know how to use a diamond. We know how to factor by grouping. And I can see that line 1, which is the problem, is equivalent to line 2, and that's equivalent to line 3, and that's equivalent to line 4. With slide and divide, maybe you save a hair bit of time, maybe. But it's kind of like a magic process, and students, when things are magical and not sequential necessarily, you're just kind of randomly doing steps, it's easy to forget them because they make less sense. But we're going to do slide and divide, I guess. So here are the steps, and they give you an example with it. But so multiply a and c together, like here they did 5 times 2. So multiply a and c together. That's going to be 2 times 3, which is 6. Rewrite the quadratic as, now notice my leading coefficient went away. So I'm just going to write x squared. It's like that 2 actually went over here, which is a difference from what we just did up above. And then plus 7x. We're copying down the rest of it. Except for at the end, you don't put the 2 anymore. You put the multiplication, the 2 times the 3, the 6. And now you factor this polynomial. Numbers that multiply to 6 and add to 7. So that's 1 and 6. And you write this out. X plus 1 times x plus 6. And this is the part that bugs me. Because, if you look at this line and that line, it's like, no way. That does not FOIL or multiply to equal the top thing. And that bothers me a ton. I mean, it's also true about this line right here. Like, the top blue line and that green line are not equivalent either. But anywho, let's keep rolling. So now we divide the constants in each binomial. The constant is the number 1 and the number 6. That's a highlighter. The number 1 and the number 6 by our a value. And our a value here was 2. So I'm going to divide it by 2, divide it by 2. Now we just created fractions. You got to simplify the fraction, if possible. Now, this first one you can't simplify. But the second one, 6 divided by 2 is just 3. Now here comes another goofy part. You bring the simplified denominators in the front of the x's. So like this one actually has a denominator, so I need to bring it out. I need to take that 2 and put it in front of the x. So it's going to be 2x plus 1. Now the second binomial doesn't have a denominator, so there's nothing. I mean, I guess you could say it's 1. You could put the 1 in front of the x, but you know, it doesn't actually change anything. So there is your answer. All right, let's try that with example number 4. So take the 3, multiply it into there. Now the 3 actually leaves here, so you get x squared plus 32x minus 33. Numbers then multiply to negative 33 and add to 32. It's going to be 33 and negative 1. And then you just call it x plus 33, x minus 1. But this obviously is not the right answer, folks. For so many reasons, when you start to FOIL this thing, it does not equal the terms up above. So you got to remember to slide that 3 down here. Slide, oh crap, I got distracted by the teacher next door. Slide, I don't know if you heard that. Slide and divide that leading coefficient underneath the constants. Underneath there, underneath there. And now simplify if you can. So this is really x plus 11. Now the second one I can't simplify. I cannot simplify. And if you could even at least reduce the fraction, do it. But any denominator that's left over once you've tried reducing goes out in front. And there we are. Now, folks, maybe you noticed the problems for examples 3 and 4 were the exact same problems we were supposed to factor in numbers 1 and 2. And if you notice it, the answers are the same. I mean, actually, coincidentally, in the top and the bottom, the binomials are switched in order, but that does not matter. It's equivalent. So here's your systems for factoring trinomials when a is greater than 1.